So you are getting an insufficient disk space message when you clearly have sufficient disk space. Confusing, isn't it? Not really. I'll explain. So there are two things you need to understand. I will not go too deep in other concepts, but I will demonstrate the befores and afters and consequences. So there are two things you need to understand. First is free disk space. There are many ways to find this out. Let's focus on this storage device here specifically for now. So as you can see here, I have 5% in use. I have 932 megabytes available. This is basically a fresh formatted and a fresh mounted partition. So nothing special there. Maybe some hidden stuff, but not really. So nothing there, nothing there. So everything is just very basic and very simple, okay? And there's nothing special. Just a freshly formatted XFS. It's XFS here. This is important. So this is an XFS file system here, okay? So lsblk minus fs. As you can see here, it's an XFS file system. Where the fuck is it? It's there. Yeah, it's there. XFS, okay? I just did worse. Let me show you again. Come on, give me a second because my PC, it has sometimes things on it, does things I don't want him to do. This is XFX, clearly XFX, okay? XFS, XF Bambo Jambo. Cool. Now, if I do an df-h, you'll see that this is my available free space of the total amount. And this is going to be the amount of inodes available on that the same storage device. So the bigger the device, the numbers will vary, of course. I'm using a 1 gigabyte partition just to make things simpler to read and faster to occur. All right. So that's that. Bigger devices, smaller devices, numbers will vary, but you can check it with the -h for human readable or the -I for inodes. Okay. So let's go back to the I, and now we just create a file there. We just do something like this, and file 1, for example, file 1.txt, whatever. And I'm not root yet. That's fine. I can just give myself root access. And now we can do the same thing here. We just touch the file. And we can do the f minus h minus I, sorry, for inodes. And you see we have consumed 1 inode. If you're watching this in the short form, come see the long form video for all the details. For the long form peeps, here we go. As you can see, we have consumed one inode. See, it was 285, now it's 284, and you kind of get the idea here. I can create file 2.txt, and we consumed another inode, and so on and so forth. But we can consume inodes faster than we consume free disk space. Okay, and that happens in specific situations where you have a storage device where you store multiple very small files. So each file or directory will consume an inode, but you are consuming inodes much faster than you are consuming free disk space. And I have made that demo. I have recorded this demo, and I will put it next on this video because it's time consuming and you guys don't have to wait for it. So I recorded myself forcing that to occur, and I will comment that next. But this is what I did. So what I did was I got a simple script. Okay, I did. You cannot really call it a script, can you? So what it's going to do here is it's going to create multiple files. Okay, txt files with this sequence: file 1, file 2, file 3 until 1000. But what you're going to do here, I am going to use the exact available number of inodes available on this storage device. So basically, I'm going to consume all my inodes. I'm going to consume all my inodes. Okay, so you guys can see better. I'm going to consume all my inodes before, and we see what happens as a consequence. So I'm going to show you next, but let me tell you, we're going to consume inodes much faster than we are going to consume free disk space. So the available inodes will decrease, and available disk space will decrease much slower. So the consequence of this is I'm going to consume inodes much faster than I'm going to consume technically free disk space. Okay, and at this point I expect you to know what inode is. But if you don't know what the inode is, every time you create a file or a folder, you consume an inode. In simple terms, an inode, it's a property on that partition that you formatted. It is inodes. The inode's scope it's different for each partition. Each partition is going to have, and file system is going to have its inodes range. Okay, in this case it's SDA1. My device is SDA1. So SDA1 at this point has available 524,283 inodes, which means each file I create is going to consume one inode. Each directory I create is going to consume one inode. Okay, and the inode will have properties of the file like file size, permissions, file name, properties, attributes, file location, etc. So a 1 terabyte file, is going to consume one single inode. Some exceptions, doesn't matter right now. Think about this like this: 1 terabyte file is going to consume one inode, and the inode will contain properties of that file. That's all you have to know. And what I'm going to do here, I'm going to create a huge amount of small files. They are going to quickly consume my inode range, my possible to create inodes, and you'll see that the file system space it will not be going to consume as fast. And we will see the consequence of that. So we'll consume a great number of inodes really fast, but the free space is going to dwindle very slowly. So this is the inode range getting consumed. Okay, so your inodes are going to be consumed like this really fast, and the free space is going to be consumed much slower. That's because I'm going to create very small files. In this case, 0-byte files. Well, smaller than this is kind of hard to do. So I'm going to shut up and show the results. I like to explain stuff so that you know me. Let's watch let's watch it. Let me see you talk about that while the video plays out, and then we come back for the goodbyes. Okay, so now we have here this is a video. This is a pre-recorded video, just full disclosure. So this is up here. It's up here. I am causing it. It's the same machine. It's a Quickie 1 machine. So up here, I'm running the script to create multiple small files, and these files are going to take up almost all the space of all the inodes of this device. If you watch here, you have 524,286 inodes. I'm going to put it just one less, just for funsies, so I can fool around a little bit later on with this. So this is going to take a while, and it's going to create multiple TXT files, and I'm just going to let it rip. And I'm going to fast forward a little bit to see what happens. And files are getting created. As you can see here, this is getting consumed. Okay, this is getting consumed here. It's dwindling. And I somewhere around here, I am going to show you the free space. So going down. Inodes are getting consumed. And as you can see here, the free space was not consumed that much. Somewhat, yeah. But I have 8% of 8% used free space and 13% used of inodes. So I'm consuming inodes much faster, and don't forget that free space is consumed even without files. So those 8% were already consumed. So let's go forward a little bit. As you can see now, I'm consuming 10% of my file system space, and I'm already consumed 51%. See? I have consumed at this point 51% of inodes, and free space is at 10%. Okay, going forward. I'm almost depleting. Okay, my inode quota. Okay, now we can go forward. Okay, at this point I have used 100% of my available inode quota. So I have no more. Even if you reach 100% of inode consumption, most file systems will have some reserves, so it will not occur immediately. But I will show the problem still anyways. Don't worry. Okay. So everything is just inodes are consumed, even though I still have free space. So I have a bunch of free space available, but my inode quota was completely depleted. Now let's see what happens there. So I'm listing here the files that were created, a bunch of files. Okay. And now I still can create a few more. I am creating some more. They are getting created, even though here we can see that our quota is depleted. File systems still have some wiggle room, not much, but some wiggle room. Of course, this will depend on the file system itself, XFS, XCF3, XCF4. They will react differently depending on the situation, but they have some wiggle room. This is me forcing things to occur because I want to force this here. Okay, no space left on device. So this is what you're going to see. No space left on device. Okay, no space left on device. So what do you think? Oh, I don't have enough free space in megabytes. So you're probably going to check if you have free space or not. And you do. As you can see here, we do have free space on the device. Megabytes are available. Megabytes are available. But you are getting shown no space left on device. Why? Because you have ran out of inodes. Okay? So if you don't have enough inodes or any inodes to create a file, if you have 0 inodes or even 0 inodes to create files, even though you have physical free space available on the partition with that file system, you are unable to create new files. Let me see if I can show you the possible error again. So this is what you get. Okay, no space left on device. This is what you see. No space left on device. So you see no space left on device, even though I have enough space in terms of megabytes. Okay, but you are unable to create new files because you don't have enough inodes to do so. So if you have a file system that you create, that you will need to store many small files, you need to be careful when you format your partition because you may need to tweak a little bit the inodes assignment. That's for another video. For now, I'm just showing you if you use the defaults. When I created the file system, I just formatted it as by default. I did not tweak anything. I just let him decide how many inodes he wanted to create. This is how much I got and what happens when I deplete all my inode quota. So if you are planning your file system to hold many small files, you need to be more careful about, well, you'll need to give a little bit more attention of your inode assignment and your inode quota. That is going to actually tell you your actual limit of files you can create, not per se the free disk space. Hope this helps. Like, subscribe, hype, and comment. I love you guys, and I'll see you in the next one. Ask any question in the comments below, or any observations, or anything you want to say. I'll see you in the next one.